Hello students, welcome to the model number 2. We are going to discuss about the failure of materials chapter. We are discussing about two contents. One is the effect of stress and temperature on creep and the mechanism of creep deformation. There are these two things we are going to discuss in this video. So let us begin with this effect of stress and temperature on creep. So we must know that some of the concept there is parameter or characteristics of creep curve. So then we can easily understand the stress effect of stress and temperature on creep. Okay, so there are two characteristics of creep curve. Okay, one is the creep rate and another is rupture, or what we called that is the time to fracture. So what is meant by creep rate means the secondary creep, or that is a stage 2 of the creep curve, is of the longest duration, and the steady state of this creep rate will be the most important parameter of creep behavior in long life applications. Okay, so such as example for nuclear power plant component that is scheduled to operate several decades. So and when failure or too much strain is not an option. So this is how the creep rate will be taking place. And for the rupture or time, or what we call as time to failure, so this is the time required to failure of material to occur at a known time, that is what will the time we call it as rupture time. So this rupture time is also be another parameter what we call especially in important in a short life creep situations such as turbine blades. Even in the power plant, the turbine blades are or military aircraft blades, and even though for rocket motor nozzles also. So these are all comes under the rupture time. So to determine this parameter, the two test must be conducted. Test is going to be conducted and to point of failure. Okay, to conduct at the point of failure. So these are the termed creep rupture test. Okay, so thus what we conclude that the knowledge of this creep characteristics of material, it allows the design of engineers to ascertain the suitability of that specific applications. That is very important. So let us begin with the how the effects of temperature stress on temperature on creep we will see. Okay, so first one is the both temperature and the level of applied stress influence the creep characteristics. And next one is at a temperature the sustainably below the zero point 0.4 tm, and after this initial deformation the strain is virtually independent of the time. So even though for the from figure we can understand with increase in the stress and temperature the following points will be noted. Okay, so first one is we'll discuss one by one. So this is the graph we can see temperature on okay curve. So from this figure what we understood that there is essentially no creep at temperature below the 40% of the melting of that point of the material. So the creep becomes more pronounced at higher temperatures, and also it be the higher applied stresses. See, you can see the creep process along the time curve. So you can see the green line, it will be took a maximum time, and comparatively this even orange line. Okay, so that t will be is less than 0.4 tm. Okay, so this is the time period, and even though for with the either increasing stress or temperature, the following things are going to be noted. Okay, first one is the instantaneous strain increases, as you see in the figure. Okay, instantaneous strain is increases. Okay, that means the creep you can observe here, it will be increasing, and steady state creep rate increases. Steady state creep will be increases, and rupture time or time to failure is decreases. So rupture time that will be decreases. So this whole creep behavior can be characterized by the equation dE by dt. That is one equation that will be influence that characteristics of that behavior of the material. Okay, so that is we can express in terms of k. Okay, k into sigma to the power of n exponential of minus k divided by rt. Okay, where sigma what we call as applied stress and qc is the activation energy for a creep. So that is constant usually, and this T is the temperature and R is the gas constant. Okay, this is all about the stress and temperature effects on curve. Okay, so okay, further we will going to discuss about mechanism of creep deformation. See, first mechanism of creep deformation uh, start with the dislocation of glide and dislocation of creep and diffusion creep and grain boundary sliding. So these are the different stages or mechanism of this creep deformation. Let us discuss one by one. What is meant by dislocation glide or motion? So already we know that the plastic deformation occurs due to the movement of dislocation in a material. Okay, so however the movement of dislocation it will be stopped by obstacles such as grain boundary or stress field around this solute, that is impurity atoms. So that will be in dislocation it is happen, and even for the strain fields of other dislocation also it is occurred. Okay, the dislocation pile up means starts to occur at obstacles as we can show. Okay, so the rate of creep is governed by the rate of escape of the piled up dislocation past the obstacles, and the possibility of happens in a creep. Okay, takes place at a higher temperatures, and atoms vibrate rapidly at higher temperatures, it permitting the dislocations of the climb to another plane, thereby the relieving the dislocation of the stress pile up the permitting them to continue the motion of the atoms. So this is a response to the applied stress, and this results what happen, the plastic formation of the material is going to be takes place. So another one is the grain boundary sliding. What happened? Grain boundary sliding means this mechanism which also explains the occurrence or behavior of the creep due to the sliding of grain boundaries. Sliding of neighboring grains with respect to the boundary that will be separates. Okay, that will be separates. So the behavior of this grain boundary is very much dependent on the temperature. So as low the temperatures, the grain boundaries do not flow viscously. So but what happen? The provides the obstacles to dislocation the motion of the increasing yield strength of the material. So however what high temperatures that is above, that is a zero point 0.5 tm or 0.6 tm, the grain boundary behaves like a very viscous liquid separating the neighboring grains and allowing to slide the against the each other. So that will happens for the grain boundary sliding, and thus this grain boundary facilities the deformation process by sliding the high temperatures. So this is about the grain boundary sliding mechanism. So let us next step generally what we call the diffusional flow or vacancy diffusion, that is also happen. So vacancy diffusion or what we call diffusional vacancy flow. So that will be one of the mechanism that creep occurring by the diffusion by atoms within the grain structure. So what happened? So vacancy diffusion mechanism is significantly at low cost. So what happened? Slow stress, so and high temperature. So since the atoms also vibrate randomly at higher temperatures, so under this driving force applied stress or atom diffuse or move from the slide side of the grains towards the top and bottom of the specimen. Okay, so this grain becomes a longer since it is applied stress does work, so and it process will be faster at high temperatures. Due to this existence more vacancies, so over period of time what happen, the movement of atoms elongates the specimen in the direction of the stress. Okay, so that will be contracted in the transfer direction, resulting in creep. So this is all about the mechanism, a brief mechanism about the creep deformation. So I hope you understood the mechanism, how it will be developed formation, and what are the different mechanism. Okay, I hope you understood, and we'll move on to the next slide. Thank you.